Well, happy Friday, Algebra 2 class. You just watched the video on what buttons to push. Probably, I don't know what you did. Here are the topics I'm going to speak of: permutations, combinations, how to use the calculator, and a few examples. Permutation, the order is important. The order is important. If you're running a race, first, second, third place is important. Third place isn't quite as good as second. Order is important. Maybe there's going to be a committee and nobody will be in charge of the committee and everybody votes on the committee. So 5 people on a committee, all people get a vote, and whatever has the most wins. Yay, you win. Nobody's in charge, everyone's equal. That would be called a combination. A way to remember this is this. Your combination lock is sort of named incorrectly. A permutation lock would be a better name. It would be a better name because the order is important of those 3 numbers you twist to open it up. So permutation is if something, the order is important. First, second, third place. A committee that has a president, vice president, and a recorder. Order is important. Combination. Order is not important. A committee of 3 people and all people are equal. How to use the calculator. We had another video on this, so let's do a couple examples. 11 people want to be chosen vice president, president, and treasurer. How many ways could that happen? Order is important. So as I showed you on that last video, and we can see this pretty good, we have 11 people. I hit math. I go over to perb. And the order is important, so I hit, not what I hit, I go math, over to probability. Order is important, that is a permutation. I go to that option, and 3 people, and your answer, are there 990 ways? Cool. Next question, out of 9 people, a committee of 3 equals. Out of 9 people, math, over to perb. A committee of equals. Order doesn't matter if everybody's equal. Option 3 and NCR, there are 3, and there'd be 84 ways to do it. 2 ways to do this problem. I'm going to do this problem permutation combination way. Is this 13 people, 13 desks? How many seating charts? Let's see, seating chart order is important. You have to sit somewhere. You can't just sit random in a seating chart. So out of 13 people, 13 desks, order is important. So out of 13 people, math over to probability, out of 13 people, permutation, order is important, choose 13, and there is a huge number. By the way, on your homework, you're going to get scientific notation. That many seating charts. Hey, this is interesting. Let's say that somebody's going to print all of those out on a sheet of paper, okay? And they can print 8 seating charts per page. Well, I would divide that by 8, and that would show me how many pages I lot. Whoa, that's a lot of pages. It is. A ream of paper has 500 sheets in it. So if I want to know how many reams of paper, I would divide by 500, and it's that many reams of paper. That is a lot of reams of paper. You would certainly buy 1 more. You would not buy 7, 55. You would buy 56 because you'd want to have enough paper. And so then if it said that this paper cost $4.79, you would take that next highest number. You will see I made the 76 because you want to buy enough. And I forget what I just said. If the paper was $5.79, that's how much paper. That would be a huge number. That'd be it. So I hope that helps you do your worksheets. We will see you. You can jump on the Google Meet or see you Monday.